Okay. So I think we'll begin about it's time.
Yeah, it's 3 minutes.
3 minutes past, yeah. Okay, yeah. So, yeah. Good morning. So today's topic is Lexical Knowledge Network and Word Sense Disambiguation. So what we did last time, by way of recapitulation, is that we did parsing, okay, and mainly did probabilistic parsing, and we understood that parsing is needed because it has to capture dependencies, and capturing of dependency is important, for example, for some very recent important applications like sentiment analysis, metaphor detection, and so on. And the probabilistic approach to parsing was a generative kind, just like the application of hidden Markov model to part of speech tagging. Okay. Here, instead of hidden Markov model, we had probabilistic context free grammar, and that was used to do parsing. Now, in case of PCFG also, we have a Viterbi-like algorithm to obtain the best possible parse given the sentence. Okay. So this was the main topic done in the last lecture. So today we would like to do lexical knowledge networks and word sense disambiguation. So with word sense disambiguation, we are entering really the layer of semantics, okay, because disambiguation needs contextual associations, clues from the context. But they also need dependencies. I would like to show the importance of dependency as we go ahead. And they need lots of resources, lexical knowledge networks or resources. So the point is this, that even though we are heavily using statistical machine learning based methods for natural language processing, deep knowledge is still needed for many of the applications. And it is interesting to note that while statistical natural language processing was progressing based on machine learning, people were also continuously spending effort in creating lexical networks like Wordnet, ConceptNet, PrepositionNet, VerbNet. We would like to discuss.
Honet, far better than all the
Which
rest.
one?
Honet.
Honet, yes.
Chinese one.
Yeah, Chinese one. So we would like to mention some of them and their philosophies. So many applications like entailment, question answering, they need deep knowledge. So here are some foundational points which are important for our discussion. We would like to distinguish between what is called syntagmatic relations and paradigmatic relations. Okay, this is very fundamental in natural language processing. So there are lexico-semantic relations like synonymy, antonymy, hypernymy, and so on. These are known as paradigmatic relations. These relations arise because of the property of the words. And syntagmatic relations essentially capture co-occurrence. For example, cat is an animal. This is a hypernymy relation between cat and animal, and that is defined as the paradigmatic relation. Whereas cat and mew, the fact that cats mew, this appears in textual corpora, and this is a kind of co-occurrence. This is also known as syntagmatic relation. Syntagmatic relation means relation by virtue of a syntagma, relation coming out of a syntactical entity, same sentence, same paragraph, and so on. So Wordnet primarily captures paradigmatic relations, and ConceptNet, for example, captures syntagmatic relations. HowNet is a nice lexical resource which combines in a balanced way paradigmatic and syntagmatic relations. Okay. An interesting fact is, which was known from some psycholinguistic experiments in English, that whenever we hear a word, okay, if you hear the word cat, the words which come to our mind by association are approximately divided half and half into paradigmatic and syntagmatic relation. I will put down the actual reference here. This is a very interesting psycholinguistic experiment, that half of the words are of paradigmatic kind coming from co-occurrence, and half of the words come to our mind from paradigmatic association. And maybe this is a universal fact about all languages. Okay. This is an interesting observation. The next important notion is that of selectional preference. Okay. And in Indian linguistic tradition, since the days of Panini, about 2000 years old, what was recognized is that there are some words which can be called as desire words. These words have desire. Okay. So, whenever they appear in a sentence, they desire the presence of other words with specific properties to be able to construct that sentence. So, for example, if I look at the word saw in a sentence, who saw and what did he saw, what did he see, those two desires have to be fulfilled of the word saw. Okay. And this is known as the notion of akanksha, which means a demand. Then there is this notion of yogyata, also called appropriateness. Okay. So, the word saw would require a seer, and the seer has to have certain properties. For example, the seer must be animate, for example, in a non-metaphorical common usage of saw. And the third notion is sannidhi, called proximity. Okay. So, words which are closer to a word have stronger influence than other words which are further away. For example, in absence of any other information, we know that this sentence cannot be disambiguated. I saw a boy with a telescope. We know that this sentence has two meanings. It is not clear who has the telescope, but if we apply the proximity principle, then since telescope is closer to boy than saw,
well, actually more,
then
because saw means also
to cut. That is
not to see.
Saw also is a noun, which is the instrument of cutting actually.
No, saw is the other verb.
Yeah. So, it can be, the verb itself has more than one sense, and part of speech also can be noun or verb. So, since telescope is closer to boy than to saw, proximity principle will assign the preposition to the noun, attach it to the noun. So, these three principles have been guiding principles of Indian approach to semantics. So,
you should say that in AI, 41 years ago, we had the preference semantics by Yorick Wilkes, and this has been used enormously in AI and NLP for AI. Preference semantics, density, semantic density of graphs representing those possibilities.
Now, the recent approaches have been based on what are called arguments and selectional preference. So, there are words which demand arguments like verbs, prepositions, adjectives, and even sometimes nouns. They demand other words as their arguments, and these arguments are typically nouns. The terminology used is arguments. The notion is that of a predicate. Okay, there are one place, two place, three place predicates. So, for example, give as a verb can be looked upon as a three place predicate. It needs an agent, it needs a direct object, it needs an indirect object. Okay. Then only the desire of the word give is fulfilled. Even if something is, one of these arguments is absent in the sentence, we should look upon this as a case of ellipsis. It is of course there in the background.
Or it is another predicate. Like he drinks, he's a drinker, one place predicate.
Yeah.
Drinks his cup of coffee.
Yeah, that's a two-place predicate. Yeah. So yeah.
There are 0 place predicates, like weather predicates. It rains. That's 0 predicates.
Yes, yes.
They can be replaced by nouns, like today, heavy wind. It's a 0 place predicate.
Yeah.
If there will be some wind, it will be windy.
Right. Okay. So the argument structure is the structure expressing the desire of a word, and this structure is called the argument frame. And then there are these selectional preferences, where there are supply words which satisfy the demand of the other class of words. So they have selectional preference. So if we take the word font, for example, the word font in English, you cannot finish a sentence with just I am fond. Okay? We have to say fond of something. So fond requires a prepositional phrase. Okay? So this is expressed as PP of NP, and this NP is something, somebody, etc., etc. So the word fond has an argument frame which consists of a preposition phrase, and the preposition phrase must have of, no other preposition. This is strict. Only one preposition can come here, of, and this has to be followed by a noun phrase. Okay? And that noun phrase should have the property of being liked. Okay? Then of course, verb argument frames are all the time used. Now, when we have lexical knowledge networks, we have a number of criteria by which these knowledge networks are constructed and analyzed. The domain addressed by the structure, the principle of construction, the method of construction, how that knowledge structure is represented, quality of the database, applications, usability mechanisms, and so on and so forth. Okay? Lexical knowledge networks have to be constructed following these principles, and they are also compared using these principles. So we will look at some examples. Probably the most popular and famous knowledge network has been Wordnet. Okay? So we look at Wordnet, and then we would like to compare other networks with Wordnet. The main purpose of Wordnet is sense disambiguation in natural language processing. Maybe I just close the door. Okay. So it is interesting to note that Wordnet was never created for the purpose of disambiguation. Wordnet was created by Fillmore, and mainly his wife was creating the data inside the Wordnet resource, and the main purpose was to teach children language. Okay. Of course, Wordnet in particular, we see that the Hindi Wordnet is these days used a lot in Indian schools. The Hindi Wordnet was created by us, and the resource has become important for language teaching. So the use of Wordnet in natural language processing for disambiguation was not the intended purpose, but now this is the main use. And what Wordnet uses is called relational semantics. Okay? So the main idea behind relational semantics is that we disambiguate a word by another word. So for example, if we take the word house, house is very ambiguous. Okay, I show here 3 meanings. House as a physical structure. Okay, the house was destroyed in flood, for example. That means a physical structure. House can also mean a family. Okay, she is from a noble house. House can mean an astrological position. Okay, so for example, Saturn in the 3rd house and so on. So here, if we use another word along with the ambiguous word, many times the meaning becomes constrained and unique. So if I put family and house together, I am very clear which sense of house I have in mind. So this is captured by a very fundamental data structure called the lexical matrix. So lexical matrix is consisting of columns where we have words. Okay, each column is for a particular word, and each row is for a meaning identity. Okay. So if I, for example, take the word bank, then bank it is shown that it has 3 meanings. One of the meanings of bank is depend. I bank on you, okay, for your support. Another meaning of bank is the side of a water body, embankment for example. The third meaning of bank is what we are most familiar with, a financial place where money is transacted. So the 3 rows indicate the 3 meanings of bank. This column is for the word bank. Okay. So each column is for one word in the language. Each row is for a particular meaning of that word. And how that meaning becomes explicit is by the presence of other words in the same row. Okay. So bank in company with rely and depend has the sense of depending. Bank in the company of embankment produces the meaning of bank as a side of the water body. This is the financial sense. Okay. So this is a very fundamental structure in knowledge networks. This is called the lexical matrix. Columns as words, rows as meaning identifiers. So here what we would have is a set of numbers which shows the meaning, unique meaning ID. So if we have this kind of IDs, then we can really link word nets of many different languages together. Okay. For example, in India, we have created the Hindi Wordnet, okay, and it has been linked with wordnets of many other languages which are operating in the country. Similarly, European Wordnet, and there is this Chinese, Japanese, Korean Wordnet, and so on and so forth. So there is a large scale effort all over the world to create wordnets and link them amongst themselves. Okay. So Hindi is linked to English, English is linked to European Wordnet. So indirectly we are also linked to the European language wordnets. Now the words are classified into 2 important categories called content words. Verb, noun, adjective and adverb are known as content words. They carry information, okay, content information. And there are what are called function words, prepositions, conjunctions, pronoun and interjection. They serve the purpose of linking words together in a sentence to produce a meaningful, coherent sequence of words called a sentence. Okay. So there are function words and content words. So most of disambiguation has happened on content words, especially nouns. There are very sophisticated algorithms for noun disambiguation. Almost nothing has happened for function word disambiguation. Of course,
they are not there. They are simply not in Wordnet. 80, for instance, is not there.
Not there, yeah.
It is astat. Chemical element.
Yeah, so these words do not appear in the Wordnet.
You cannot disambiguate, they are not there.
Yeah, but PrepNet, produces preposition.
Wordnet doesn't.
No, but there is of course a controversy with respect to prepositions. Prepositions, it is not very clear if they are purely function words or do they belong to the set of content words also. This is really at the boundary for content word and function word.
No, they are clearly function words because in an abstract presentation, they disappear. They are represented either as place in the argument frame or semantic relation. Very clear. And pronouns, actually, very often in linguistics are content words because they, very often, not always, they refer to some content. They do have a lexical content, you have to find it out. Unless you have a dummy one like it rains. Okay,
that's a pleonastic actually.
Does not, it does not refer to anything. It's not a pro anything. It fills simply a syntactic position.
Yeah, it's called pleonastic.
So, in linguistics very often, in grammar, so they would say that pronouns are a special kind of replacement elements. They have their own place.
Yeah, the difference between pronouns and nouns. Okay, this of course has been dealt with quite extensively in what is called binding theory. So pronouns get their reference from the same syntagma, whereas nouns get their reference from outside world. Okay, so that's why pronouns are kept in the category of function words.
Yeah, most usually they do that. Plus the syntactic behavior is very often particular.
Yeah.
Sometimes it's glued to the verb, sometimes it can be inserted like clitics, and you cannot insert a noun, etc.
Yeah. Then, since we apply a lot of machine learning techniques to word sense disambiguation, there is large effort at creating what are called sense marked corpora. So here in this sentence, for example, I have enjoyed Los Angeles every time I have been there, regardless if it was for work or pleasure. So this sentence has a number of content words. Have, I, these are this have is an auxiliary, therefore it is a function word now. And there are many other words like work, pleasure, which are highly ambiguous. So these IDs come from the Wordnet. Okay, they are placed on the words. So we create sense mark corpus this way and pass it through a machine learning algorithm. We will look at some algorithms. And this requires a lot of effort because the words like pleasure, they have senses, and many times the senses are very fine grained. It is not easy to separate them. So the first sense of pleasure, which is most frequent, is a fundamental feeling that it is that is hard to define, but people desire to experience. He was tingling with pleasure, for example. So these are different senses of pleasure, and when we create sense marked corpus, the annotator has to be very careful with the particular choice of a sense. It is never very easy. Okay, and the basic principle is this: words in natural languages are polysemous. However, when synonymous words are put together, a unique meaning emerges, and we make use of what is called relational semantics. So there are different kinds of lexical and semantic relations in the Wordnet: synonymy, hypernymy, antonymy, meronymy, gradation, entailment, troponymy. So 1, 3 and 5, that is synonymy, antonymy and gradation, these are lexical, word to word relationships, whereas other relationships are synset to synset, meaning to meaning relationships. That is the convention followed in Wordnet. So when we apply these relationships, we really get a graph structure, which is the Wordnet. In the graph, the nodes are synsets, okay, the set of synonymous words. For example, house and home is a synset, and it is a special kind of dwelling or abode. Okay.
Guest room should be included by guest house.
guest room.
Guest room is the part like veranda, etc.
Yeah.
Guest house, I guess.
Yeah, I think so. Yes.
Guest room is not a kind of home.
Yeah, could be. Yeah, I think guest house should be. So, hyponymy is generalization. This side from a upper node to a lower node, the relationship is called hyponymy. It's a specialization, and going upwards, it is called hypernymy. It's a generalization. Then meronymy is part of relation. So, kitchen is a part of dwelling, for example, bedroom could be a part of dwelling or abode. And this part is important. This is called gloss, which describes the concept. For example, house is a place that serves as the living quarters of one or more families. Okay. So, gloss, the synset members, the related entities through meronymy, hypernymy, etc., forms the Wordnet structure, and it looks like really a graph with different kinds of relationships. So, the moment we have a structure which is a graph, computer scientists become interested immediately, because now you can discuss the property of the graph in terms of in degree, out degree, density, navigation algorithms, okay, breadth first search, depth first search, and so on and so forth. So, a lexical knowledge network in the form of graph is amenable to lots of nice algorithms. Now, one particular relationship which is very complex and subtle is the entailment relationship. Okay. Now, entailment relationship can be with temporal inclusion or without temporal inclusion. Okay. In temporal inclusion, you could have with troponymy or without troponymy. In non-temporally included entailment, you can have backward presupposition or cause. So, let us take examples of this. So, this particular tree shows relationship between verbs, okay, and verbs have been very difficult to semantically represent in any lexical knowledge network. Okay. So, if we take limp and walk, limping is a kind of walking, lisping is a kind of talking. So, this is what is called the manner of relationship. Manner of relationship is given a term called troponymy. So, limping and walking have the relationship of manner of. Limping is a manner of talking, walking. Okay. And this is also temporally included, coextensiveness. So, if somebody is limping, he or she is also walking at that time. Okay. So, that is why it is plus troponymy plus temporally included. You could have temporally included, but not troponymous, not manner of. For example, snoring and sleeping. Snoring is not a manner of sleeping. Okay. Snoring is a feature of sleeping, but it is temporally included. If somebody is snoring, that means the person is sleeping. Then you can have verbs which are not temporally included. For example, succeed and try. So, succeed and try. So, try must precede succeeding. Okay. Tying and untying, tying must precede untying. So, this is non-temporally included, and this is known as backward presupposition. Okay. Succeeding implies trying. Then there is this cause and effect relationship like raise and rise, give and have. These are also not temporally included. Now, why am I spending a few minutes on this? That is because there is this new field of natural language processing about 5, 6, maybe 7, 8 years old, and is understood to be very, very fundamental to NLP, called textual entailment. Okay? And in textual entailment, we need to capture the relationship between the verbs of two sentences which may have paraphrase relationships with each other or may have implication relationship with each other. Okay. There are many times the basic task is to detect entailment of verbs. This structure is also very important for question answering systems. Okay. So, all kinds of this kind of linguistic knowledge is embedded, for example, in a sophisticated question answering system like Watson. Okay, all of us have heard about IBM's Watson system. This uses very powerful machine learning algorithms, but they also represent lots of knowledge of this kind. Okay. So, this is a very important diagram for us, because they capture verb relationships. Now, the principles which are operating in creating synsets are minimality, coverage, and replaceability. So, when a Wordnet is created, when it is created from first principles, it picks all the senses from a good standard dictionary, obtains the synonyms for each sense, and this actually needs very hard and long hours of work. Okay. So, the English Wordnet took about 10 years to be completely created, refined, and usable. Hindi Wordnet took 6 to 7 years. Okay. European Wordnet was done in 3 years, but that was in a mission mode project. The other approach to synset creation is by what is called expansion approach. So, we pick the synsets of a language, let us say English, and we get the words of the target language. But we should be very careful that the synsets are not translated, okay, because that can give rise to what are called false friends. If two languages have descended from the same parent, okay, many times they share words, but the words might have shifted their nuances as time goes. Now, I illustrate this expansion approach through a English-French example. Hopefully, the French example is correct, and I also show what should not be inserted in the French synset. So, English synset here is bank, which is a sloping land, especially the slope beside a body of water. They pulled the canoe up on the bank. He is sat on the bank of the river and watch the currents. This is the meaning of bank here. It is not financial bank. The corresponding French synset, which I saw from the French Wordnet under European Wordnet, is rive and rivage. Rive, okay, rive and rivage. This should not be in the synset. It is not there. I just put it there to show what kind of mistake people make when they create synset. Okay. So, words should not be there because rive and rivage are kind of board. Okay. So, the words inside the synset have to be strictly synonymous. You should not have a word which is a hypernymy or hyponymy of another word, a common mistake which Wordnet makers always make. So, I believe this word board should not be in the set. Is it okay? They are not synonymous.
Yeah, but the notion of synonymy is not enough because they are never synonymous in a synset. They share something like rive and rivage as not synonymous.
Not synonymous.
They cannot be replaced. You cannot say le rivage de la rivière.
Oh,
That's impossible.
okay.
Unless it is Amazonia, it's like an ocean.
Okay. But does
Rivage de la mer.
but are there some sentences where rive and rivage can be replaced? No sentence can replace?
Yeah, they share some common elements,
Yeah,
but they
yeah.
are not synonymous, which means fully replaceable.
Mm-hmm.
Fully replaceable. Like
You cannot find any sentence where they are replaceable?
They can, no. As I say, it's normally synonyms, if you have synonyms, they are replaceable in all contexts.
No. Pure synonyms don't exist.
Mean the same thing, they are
No.
in the same
Pure
place.
synonyms don't exist.
Yeah, of
Yes,
course.
no.
And this
So
is
you
why
cannot.
in Wordnet, if you take Wordnet,
Yeah.
they have collections of verbs that share some common meaning, like judgment.
Common,
are
yes.
certainly not synonyms.
Yeah. So depend and rely, for example, are synonyms, but they cannot replace each other in all contexts now. So we are not talking about pure synonyms. We are talking about words which have some examples of contexts where they can be replaced.
Yeah.
If you say rive and rivage can never replace each other, then of course it is a wrong synset. But the common mistake that people make is introducing hypernymy and hyponymy. which should always be avoided. Okay. So, can you give me some synonyms here? Synonyms of bank?
No, I mean, this idea of Wordnet is simply wrong. That's my problem with Wordnet. They call them synonyms, sets of synonyms, and they are not.
Mm-hmm.
We had I remember back here in 2006, a visit by somebody who did a talk like that at Calling, Manchester, and he did a seminar on Tom Richens, showing that in all examples you could find, there were never full synonyms. But it's a quasi-synonyms. If you accept to replace the notion of synonym by quasi-synonym,
yeah, that's what they say actually.
It's okay.
Yeah. Yeah. So, so what about this? Is this a correct synset between English and French? Trust, swear, rely, bank. We
like compter sur, avoir confiance are not synonyms.
Oh.
No, not at all.
I mean, they can never replace each other.
Se fier and avoir confiance en is almost a synonym. Those two.
Okay. What about this?
This is a variant of avoir confiance. Actually, it's a support verb.
Okay.
Okay.
Yeah. So.
And okay, the example is wrong. Nous pouvons faire confiance à Dieu. Nous pouvons avoir confiance en Dieu. So the example is wrong. So very often the information is simply wrong. Preposition. The preposition here is just wrong.
Okay, this should be something else.
This should be a.
Ah, okay. Yeah.
But avoir confiance en.
Okay.
And it's absolutely wrong or absolutely true. You cannot say yes in between. Statistically, it should be this or that. No. Faire confiance à, avoir confiance en.
Okay. So this, of course, should be corrected. So maybe here I made a mistake, but this is from the French Wordnet.
But compter sur, there is rely on the left.
Yeah.
That compter sur is rely on somebody.
Yeah.
So I don't know how to deal with that.
Yeah. So
rely can be rely wider than to rely on.
Yes. So when we we are not talking about the syntactic participation of the words. When these words are used in a sentence, they probably need other prepositions, conjunctions, etc. But the Wordnet stores essentially content words. Sometimes they do, of course, store phrasal verbs.
Is in rely on. You can swear, for instance, I swear by this.
Yes.
But I swear. Here, you don't know whether it has
that is
argument or not.
No, that is not the sense of swear here. It's a different sense of swear.
I mean,
yeah.
Swear is different from swear by.
Yeah.
I swear,
Yeah. So
but that's another problem.
No. But they also give the syntactic frames. They give syntactic frames with the synset. Okay.
Actually, they are compound predicates. It's like to give back or to sum up, etc. The up, the main preposition there is contained in the lexeme. If you want to.
Yeah, and of course there are phrasal verbs like look down, up, and put on, etc., which appear as such.
I swear by God, not swear.
So then there are these antonymy relations, which is opposition of meaning, and many different kinds of antonymy appear, like size antonymy, quality antonymy, state antonymy, personality, etc., etc. So Wordnet-like resources try to capture this kind of fine grains of antonymy. They also try to capture fine grains of meronymy. So meronymy means part of. So head is a part of body, wood is, a table is made of wood, tree is a part of forest, speech is a feature of conference, okay, and so on and so forth. All these are grouped under meronymy, and different Wordnets try to capture as many of these as possible. In Hindi Wordnet, we try to capture as many of these as possible. Now, a very interesting property of meronymy is that if you have A meronymy B, B meronymy C, then A and C need not be meronymous with each other. The transitivity does not hold if the two meronymy relations are of two different kinds. Okay? So, a door, so for example, a handle is part of a door is part of a room, but it will be strange to say a handle is a part of the room. Okay? That is because these two meronymies are of two different kinds. And why do we bother? We bother because inferencing, question answering, they need to worry about this kind of fine grained meronymy.
What are the two different kinds for this example, handle, door and room?
Door and handle. So, handle would be part of door. Okay. Handle is part of door. This is component object, and door part of room. Place area maybe. Yes. So that's why
you cannot say that door is located in the room. It's part of the room.
Yeah, but handle being part of the room sounds very strange.
Maybe it sounds strange, but in this example, it is the same. Meronymy subrelation. So actually, it sounds strange simply because it has degree 2. But in this case, transitivity applies.
In this case,
you cannot find any other of those subrelations that would hold.
No. So let's see. Speech is a part of feature of conference, and let's say, remember. So this, for example, you can say a leaf is a part of the tree, which is component object, but it will be strange to say leaf is a part of forest.
Yeah, for this example.
Yeah. Here transitivity fails because there are two different kinds of meronymy.
This example is a good one.
Leaf is part of tree, tree is part of forest, but leaf part of forest is strange. Okay. Yeah.
Please, how do they deal with the fact that okay, there is an English Wordnet, but in different parts of the world, words can mean different things in English, Australian English, and so on. For instance, in French, if you take drôle, drôle is an adjective, means funny. But if you go to south west, Bordeaux area, it's a noun and it means a young boy.
Yes.
So
yes.
Do they include such distinction?
Absolutely. Yeah.
So it would be huge.
Yeah. Of course.
So you have to make Australian English or.
Yeah. So Hindi, for example, has about 6 to 7 dialects, and those dialectical words are also placed in the Wordnet in appropriate synsets. Okay. So the word shiksha, for example, shiksha means education in Hindi. Okay. But there are different dialects of Hindi where shiksha means punishment. Okay. So education and punishment. So in the synset of punishment, the word shiksha appears with a note that this is a particular dialect of Hindi. So that's how it is. Yeah. So Wordnet creation is a very time-consuming, intricate activity. Then there is this interesting relation called gradation, which places the words in a spectrum of semantic nuance. So childhood, youth and old age, hot, warm and cold, sleep, doze and wake. So the intermediate word is a word between the two extreme opposites. Warm is between hot and cold. So if some of us are wondering as to why all this pain, why do we take so much of care to create a lexical resource, the reason is really very difficult applications like question answering, sentiment analysis, metaphor and so on. You cannot address those difficult applications without strong lexical resource, whatever machine learning you apply.
Despite of this, the question answering is still not solved, right?
In spite of all this?
Yeah,
No.
question answering is still not solved.
Well, they do not do it now.
Yeah.
But hopefully in future they will. Okay. Yeah, many applications which were unthinkable maybe 10 years back are now being solved. Okay. So Wordnet is really a collection of these kind of synonym sets, So, for example, forest, wood and woods, tree is a part of the forest. So, this is the holonymy relations going down, meronymy relation going up, okay, limb, tree, branch, etc. Then hypernymy, hyponymy, these are synsets and so on and so forth. So, it is an intricate lexical knowledge network. Now, the recent development in the Wordnet is to be able to capture metonymy, okay, which is concerned with metaphors. So, for example, if we have a sentence like he is a lion in the battlefield, okay, then a machine or even a child would get confused, how can a person become a lion? But lion is a metaphorical usage, and this kind of metaphorical relationships are being captured now in the next version of Wordnet, okay. And that is of course a very, very intricate task again, and I have lot of observations on metonymy, but we do not have time today. Now, an important point here about is this 73%. So, Wordnet contains very little syntactic information, as you pointed out just now, rely on, swear by, those things are not explicitly captured in the synsets. And then sense distinctions are very fine grained. It is seen that if you give the Wordnet to a person and give an ambiguous word, the inter-annotator agreement, okay, is 73%. This is also called kappa score. So, this agreement is 73%, means even between human beings there is just about 70% agreement on the average on senses. So, it is difficult to expect algorithms in general, word sense disambiguation algorithms in general, to be able to cross this.
You read by 73%. The kappa coefficient is between -1 and +1.
Minus between
Yeah.
between
Kappa
0 and 1.
coefficient means the total disagreement is -1. So what does it mean 73%?
No, so this means 0.73. So
Then that is not the kappa coefficient.
no, it is a kappa score.
No, kappa is between -1 and +1.
But you can always make it 0.73, no?
No, it doesn't mean anything. It means if you have 70%, it means between 0 and 100.
Yeah.
For
Yeah.
instance, this cannot be said to be a percentage.
No, I think this is just nitpicking. So this kappa score can surely be adapted to a scale of 0 to 1 also. And I can
Kappa coefficient is between -1 and +1.
Maybe,
That's the
but
fact. So if you say that,
Hmm.
you don't know whether it is plus 0.7
it is plus.
or whether you have to divide by 2 to say that it is 1 plus 70% over divided by 2 makes a big difference.
No, I don't think so.
Coefficient is between -1 and +1.
Yeah, could be, but I could maybe work it out in the.
reflects the agreement or disagreement
Mhm.
between judges. If there is total disagreement, it's -1.
But it could be looked upon as 0 also, no?
It cannot be looked up. It's a definition, mathematical
No.
definition.
No, maybe I'll do it in another class, maybe. But so this point says that even for human beings, sense distinction is quite difficult. Okay, in general, you do not get a lot of agreement in general over all possible domains, but in specific domains it has been possible. So now we come to word sense disambiguation algorithms, because all these lexical resources have to be used in a computational framework, right? So if you have if you know of this, how will you complete the rest of the sentence? Where there is a will, what is the next part? Do you know?
There's a way. There's a way.
Where there is a will, there is a way, but it could also be where there is a will, there are many relatives. Okay, so do you understand the joke? I don't know. So will means a deed, a document transferring property. So if there is a will, then many relatives come looking for that property. Okay, so the word will is ambiguous. Okay, it can mean wish, desire, or did. So, word sense disambiguation needs to distinguish between these kind of senses of words from many different domains, and there has been many times a question in natural language processing as to is word sense disambiguation really needed. Okay. Information retrieval people have always asked this question, machine translation people ask this question, pure machine translation people do not believe that word sense disambiguation is needed. Okay. But I will show in the next lecture on sentiment analysis that senses of words provide very powerful features for machine learning algorithms also. Okay. So, the word sense disambiguation clue can be far away from the word which is disambiguated. If you look at this sentence, the word ambiguous word is bank. Can you see where the clue is? If you read it from left to right, can you tell me where the clue for the disambiguation comes? No, a river bank also can be closed to public. Huh? Yeah, so far. So between bank and money. So, you can go on reading from left to right and still not understand the sense of bank until you have looked at money here. Okay. So,
but it's large. It's 31 words, so it's not a very big sentence. In many cases, it's not also across sentences.
yeah.
Very often, what you say is true, but across a longer distance from one paragraph to the next.
Yeah, it could be.
Yeah.
It could be that far
So
also.
that's,
It could be that far also. But here the clue comes only after so many words here. Okay. So, word sense disambiguation algorithms are typically divided into knowledge based and machine learning based. Under machine learning again you have supervised, unsupervised and semi supervised algorithms. Then we have hybrid algorithms which combine knowledge based and machine learning based techniques. Okay. So, this literature is very rich. I will give a glimpse of some of these algorithms. Okay. Now, the first approach is what is called overlap based approach. This is the oldest approach to word sense disambiguation, and very interestingly, this approach, even though it is extremely fallible, extremely naive, it keeps coming back to word sense disambiguation literature again and again. Okay. For example, we see that in last year or two, overlap based approach is again making a comeback because of deep learning and word vectors. Okay. People are using this word overlap based approach idea in creating word vectors and then disambiguating. Okay. So, that is something I would like to show in the last lecture on deep learning. So, the idea is very simple. It is also called Lesk algorithm. If we have this sentence, on burning coal we get ash. Okay, on burning coal we get ash. The word ash is ambiguous. The noun ash has three senses. The first two are from the tag text. Ash means a residue that remains when something is burnt. Okay. The second sense is ash tree, and the third sense is wood from the ash tree. These are the three senses of the word ash. And in this particular sentence, which sense is applicable? Of course, the first sense, a residue that remains when something is burnt. So, in the Lesk algorithm, we create what is called the context bag and the sense bag. Okay. The sense bag is created from the gloss, all the words in this gloss and the synonymous words here, and context bag comes from the sentence, on burning coal we get ash. So, here the context bag consists of get, coal and burn, okay, and the sense bag consists of the words here. So, when we create a overlap between the context and the sense, we find that there is a common word here, burn, and therefore, this is the winner sense, as simple as that. okay, an extremely naive algorithm. You simply see the overlap between the context and the one of the senses here. That is all. Okay. And of course, this example shows that the algorithm is extremely fragile. It can always be beaten, it can always be defeated, but still it comes back again and again in the Word Sense Disambiguation literature. Yeah.
I think this is actually not the canonical version of the last algorithm, this is a simplified version. But the original algorithm actually considers all overlaps between pairs of definitions, the pairs of definitions of the senses,
Yes.
and then tries to find the combination of like the select senses for all words that maximize the sum to pairwise overlaps.
So, you mean extended LESC maybe, which considers overlap consisting of everything, consisting of hypernymy, hyponymy.
It's different than that. So if you see, let's say you have two words, they should have three senses.
Yes.
You're going to evaluate all the possible combinations of
Yeah.
sense selections for
Yeah.
those two,
Yeah.
and then take the sense combination that gives the maximum score.
Yeah, I think you are talking about all word WSD. Okay, I am talking about targeted WSD. Okay, this is targeted WSD. So, in targeted WSD, we concentrate on a particular word, okay, and try to disambiguate that. Many of the sense eval competitions are on targeted word, for example. So, here the target word WSD concentrates on ash and tries to see the overlap between context and the senses. Okay. So, this has of course been modified to include many more words from the neighborhood of the graph. So, that makes use of, for example, hypernymy, hyponymy and so on. So if I have a word sentence like this, on combustion of coal we get ash, not on burning of coal, on combustion of coal we get ash. So, here from the senses we will not get any overlap, okay. But if we also introduce the hyponymy, okay, fly ash for example, here we hit the word combustion, okay, and then we get the winner sense here. But this algorithm also is fragile because of what? Because of a phenomenon called sense drifting. Okay. All this overlap based algorithm can be sense drifted, and if we include more and more information from the neighborhood, the chance of sense drifting increases. You can also include noise, but very surprisingly this algorithm comes back again and again in different shapes. So, there is this Walker algorithm for example, which is based on thesaurus, and here the algorithm is very simple. If the sentence is the money in this bank fetches an interest of 8% per annum, it is again targeted WSD, the word is bank. There are two senses of bank, finance and location for example. Now, we look at the words in the neighborhood and try to see to which sense they contribute. So, here for example, the word interest contributes to finance sense, 0 to location sense, fetch 0 0, annum +1 here, 0 here. Totally we have 3 contributions in the finance sense, 0 contribution in the location sense, therefore, this is the winner sense. Okay. And this of course relies on a good thesaurus. Now, one thing I have not seen is the combination of thesaurus with Wordnet. I have not seen any algorithm in the WSD literature which combines thesaurus with Wordnet, maybe something to think about. Then time is limited. I will just mention a few algorithms. One is based on conceptual density, which is due to Aguirre and Rigau from 1996.
To Wilkes 71 or 73.
But he does not use the term density.
He used conceptual density, semantic density, of course.
Okay. But using Wordnet? No.
No, it was far before Wordnet.
Yeah,
far before. They had graphs like Quillian's graphs.
Okay.
Semantic graphs.
I see.
They had already.
Okay. So, the idea of conceptual density is based on a very important principle from ontology, which is the similarity between two entities depending on their path length, okay, and their height in the ontology tree. To give you an example, the similarity between cat and dog depends on the distance between cat and dog in the ontology tree, but it also depends on the height of cat and dog in the ontology tree. Okay. So, you could for example have animate, inanimate here, they also have the same distance, maybe a length of 4, path length of 4, but that similarity is much less compared to the similarity between cat and dog. So, similarity of entities depends not only on the distance between them in the ontology, but also their height. So, conceptual density essentially captures this, and there is a formula to capture the conceptual density, which is here. Okay. It captures the height of the hypernymy tree, the number of nodes in the hypernymy tree, and so on and so forth. And a nice example is given here. This is also targeted, these are all word WSD. So, the jury praised the administration and operation of Atlanta Police Department. Operation has 8 senses, administration has 3, jury has 2. So, when the algorithm finally terminates, we find that there is a tree of the Wordnet which is described with maximum number of senses in this part, okay, and this is not so dense, and therefore, this becomes the winner subtree from the Wordnet, and the correct senses appear in this subtree. This is called conceptual density based, and it is also actually an overlap based algorithm. A more recent work is using random walk based algorithm, is due to Sinha and Mihalcea. So, here if we have the sentence, the church bells no longer rang on Sundays, then the content words are bell, ring, church and Sunday. Sunday has only one sense, but church has 3, ring has 3, bell has 3 senses. So, first a graph is created which is based on the similarity of these senses, and the similarity is calculated from the synset overlap, the similarity of the 2 synsets in the Wordnet. Okay. That uses things like Resnick similarity, Lin similarity, there are many similarity measures in the Wordnet, and then a PageRank algorithm is run on this whole graph, and the winner senses emerge. This is also an overlap based algorithm essentially, and PageRank of course is a well known algorithm which is adapted for this particular work. So, in knowledge based approaches, which is of overlap based idea, Lesk algorithm, extended Lesk, conceptual density, random walk, Walker algorithm, this is the kind of accuracy people get. Okay. This can be a bit misleading because they are not on the same corpus, they are not on identical corpus, but this is representative. We can see that Lesk algorithm achieves about 50 to 60% accuracy, thesaurus based approach about 50% accuracy, conceptual density 54% on the Brown corpus, okay, extended Lesk just about 32%. Why does the accuracy reduce here? Because of sense drift, a lot of noise is introduced in the overlap. Okay. So, this is known from knowledge based approaches to word sense disambiguation. In supervised approach, again there are many known algorithms. One is based on knife Bayes. This also makes use of the argmax idea. The best possible sense is obtained from probability of the sense given the feature vector of the word. Okay. The best possible sense comes from an argmax computation. Then we make use of knife Bayes assumption, get the features and compute the best possible sense through this kind of product. Okay. This is just like part of speech tagging. So, knife Bayes has been used, then decision list based algorithms have been used. This is also based on sense mark corpus. Here is an example. The word plant can mean plant from botany, or plant can be a manufacturing plant. So, we capture word associations from the training corpus, okay, word associations, and the clue words are used together to create a decision list. That is the data structure. So, when a new sentence comes, we take the clue words and traverse the decision list to get the correct word. Then there is exemplar based word sense disambiguation, but most successful has been word sense disambiguation using support vector machines. Okay. So, I would like to do a bit of support vector machine in the next class. So, there is this training phase, testing phase, and it is based on features. Now, what kind of accuracies do supervised algorithms report? Supervised algorithms seem to be doing about 10% better than knowledge based approaches. Average accuracy for overlap based approaches hovers around 40 to 50%. Supervised approaches we find is around 60%. Again, we should take it with a pinch of salt, because the corpus is not comparable. They are on different corpora. However, most of the reported literature says about 60% accuracy. Now, I would like to just show you one piece of work which is very recent. One sec. Yeah, this is a piece of work which we are going to present next January in AAAI in Texas, Austin. Yeah. So, this is unsupervised word sense disambiguation using Markov, random field, and dependency parser. Okay. That will be presented next month in the AAAI 2015 work. And the idea is that given a sentence, we create a Markov random field, okay, Markov random field from the senses in the sentence. And the basic approach is as follows. The sense of a word depends on the sense of other words in the sentence and not on the words themselves. Okay. So, the clues come from the words, of course, but we believe that if we look for clue in the sense, that is, we create a graph from the sense of the words, just like in the PageRank algorithm, and make use of that. That is much more useful than working with words. Okay. And also, the sense of a word depends only on the sense of few other words. The clue word is actually not many. The clue senses are not too many, and therefore, it is useful to capture the dependencies in the sentence, which are the words which are really dependent on each other. So, there is this notion of selective dependency, and then we construct a Markov random field, maximize the joint probability using map inference query. So, this is a all words WSD algorithm. Okay. So, all words WSD algorithm. The block diagram is as follows. Given a new sentence, we use Stanford Postdagger and link grammar to capture the dependencies. Not all words are useful for disambiguation. Only dependencies are dependent words are useful. Then these are used to create edges and nodes. Okay. The whole random field, of course, consists of nodes and edges. Node potential are created and edge potential are created. Edge potential is created from similarity measures or relatedness measures. Now, we can do this because there are many different algorithms to produce semantic similarity. Okay. This area is very rich. We can make use of Resnick, Lean, then CHW. Yeah, there are Dice coefficient, Jacquard similarity, many related measures exist. And the node potential is created from the density of the word or the frequency of the appearance of the word in the Wordnet structure itself. Okay. So, the papers gives all the details. We create node potential and edge potential, and then the inference algorithm is run on the Markov random field to produce the tagged sentences. Okay. What kind of accuracy do we get? So, maybe that is why the paper got accepted, because in terms of idea it is a simple application of Markov random field, but we seem to be doing better than the reported results. Though, so sense eval is a standard task, sense eval 2, 3 and sense eval 2007, all their corpora are available. Okay. And these are standard benchmark data for word sense disambiguation algorithms. So, we have made use of link parser as well as Stanford dependency parser to capture the dependencies and create the graph and impose Markov random field. So, we find that in the 2007 sense eval data, we are doing much better than reported algorithms. This is Navigle 2010, Aguirre 2013. They report 41%, 43% accuracy. We reach about 50% accuracy. Yeah.
And what are the methods there? Are there any distributed semantics methods?
No, I don't remember the actual details of what they do, but they are all unsupervised algorithms. We are comparing unsupervised algorithms with unsupervised algorithms. Yeah. So Mihalcia 2005 is this page rank algorithm. Okay. So Aguirre 2013 and Navigle I need to see what they are, but we seem to be doing about 10% better than them here, maybe 6 to 7% better for sense eval 3, and sense eval 2 slightly better than Aguirre, but better than other algorithms. They are well known reported algorithms in unsupervised word sense disambiguation. And it seems the choice of dependency parser does not really affect. It can be link parser or Stanford dependency parser. And we can investigate the accuracy for different parts of speech. Okay, different parts of speech. So noun, for example, verb, adjective and adverb. And our algorithm is doing better in all words, doing less than Aguirre in noun, doing better in verbs, doing better in adjectives, doing better in adverbs. Adverbs we are doing very well, okay, on sense eval 3 data. In sense eval 2007 data, again we have very high accuracy for adverbs and good accuracy on nouns. Okay. So, all these are completely unsupervised WSD algorithms, and unsupervised WSD is very important in the field, because many languages do not have the resource to create sense mark data. It takes a lot of time, lot of people to create sense mark data. So, this is one piece of work which is very recent, and our results seem to be strong. Okay. So, now in the remaining time, I would like to show you another set of lexical resources. I want to spend some time on PrepNet, okay, preposition network.
So when you said unsupervised, so you didn't even use Wordnet, right?
No, Wordnet is to be used because this provide you the identifiers, but no sense mark corpus. So, PrepNet is a very important resource, and people are realizing that natural language processing cannot be done with only content words. Okay. Function words play a very important role. So, PrepNet is for describing syntax and semantics of prepositions. Prepositions are critical. They are useful in indexing, knowledge extraction, entailment, question answering, and they are very important because they convey many basic meanings. They convey the meaning of instrument, means, comparison, amount, approximation, localization, etc., etc. So, there are examples of preposition use. Instrument, for example, eat with spoon. Localization, source, came from Paris, destination went to Grenoble. Temporality, duration, works for 5 hours. Start, worked since 3 am and finished at 10 pm. Means, succeeded through hard work. Comparison, taller by 5 inches. So, any of these ideas, instrument, localization, temporality, means, comparison, they need preposition. You need prepositions in English, and you need postposition, suffixes, etc. in other languages. Then most prepositions are ambiguous. That is another problem, because their translations differ when you go to another language. With, eat with spoon, sit with a friend, succeeded with hard work, hotel with a pool. All these prepositions are same, but their senses are very different. If you translate it to another language, the translation becomes very different. At, came at 9 pm, stayed at Grenoble, stared at the face. At is again ambiguous. Through is ambiguous, to is ambiguous. Okay. So, this Patrick Saint Dizier, he started this project called PrepNet, and it was reported in IJC NLP 2006. I think the project is making progress continuously, and it is structured at 2 levels. The first level is called abstract notion level, and the second level is called language realization level. Okay. So, prepositions and suffixes, they are of course not universal, but they capture something very universal about language. Prepositions have equivalent of postpositions and suffixes in Indian languages. In Hindi we have postpositions, Bengali also postposition, in Marathi we have many times suffix equivalent of prepositions. So, there are also what are called complex prepositions. In English we have in spite of, in accordance to, in Hindi we have ke saath, ke babajud, etc. And this takes us to what is called multi-word detection problem. Many times they are contiguous, but sometimes text can come inside them. So, the main features of PrepNet are there are 196 preposition senses, and the organization is like what is called lexical conceptual structure, a well known knowledge representation scheme due to Bonnie Dorr. There are 65 primitives, and the whole network is multilingual. The methodology of construction shows that the project in charge has studied many languages, studied many bilingual dictionaries, and there were prepositional lexemes with constraints and distributions. It took 1.5 man years, and the structure is based on records. So, the general architecture is preposition is categorized into 3 levels: family, facet, and modalities. 12 families are defined. The most important part is what is called the abstract notion. So, localization is an abstract notion, and it has facets like source, destination, via, fixed position. If I take this preposition from and to, they are localization prepositions. So, went from Grenoble to Paris via Lyon. So, here the via facet is Lyon, destination facet is Paris, source facet is Grenoble. Then you can have quantity with facets like numerical quantity, referential quantity, frequency, iterativity will come in 3 hours, divide into 2 parts, and so on. So, the abstract notion here is quantity, localization quantity. Then you can have manner, and manner also can have facets like attitude, means, imitation, agreement, analogy. For example, in agreement facet of manner, he behaves according to the law. According to is a complex preposition, which is a manner preposition with a facet as agreement. You can have accompaniment as a abstract notion, and facets can be adjunction, simultaneity, inclusion, exclusion, and so on. Adjunction, stick with French fries. Exclusion, they all came except Paul. Then another abstract notion can be choice, an exchange with facets as choice of alternative, substitution. So, substitution preposition can be sign for the head in his absence. Choice can be among all my friends, he is the funniest one. A very important class of prepositions is causality prepositions. Then the facets are cause, goal, intention, purpose. The rock fell under the action of frost. Under is the causality preposition, and under is also used in locality preposition, for example, localization preposition. Then you can have opposition with two ontological distinctions, physical opposition and psychological or epistemic opposition. Opposition to act contrary to one's interest. So, contrary to is a complex preposition here with the notion of opposition. Okay. Ordering with facets as priority, subordination, hierarchy, ranking. At school, she is ahead of me. There is an ordering preposition. Okay. Then the last few are instrument and other groups. Instrument is an extremely important preposition, complex case with interesting multilingual aspect. And then theme prepositions can be theme prepositions, like a book on dinosaurs. Okay. On can be a localization preposition also. So, this shows that this abstract notion is an attempt at classifying prepositions into different groups, and these are critical for semantics, absolutely critical. So, instrument can be artifact, means, or method. Artifact can be eats with spoon, means can be went by horse carriage, method can be solved with programming. In Hindi, the instruments are captured by a number of prepositions which have intersection of meaning. So, for example, the word say is a postposition, and there are synonymous postpositions like ke dwara, kar, ke karan, and so on. So, syntactic frame is postposition based. In PrepNet as well as any postposition recording, we have to give the syntactic frame also. Now, there are interesting usage restrictions. For example, say can be used only with concrete, dwara is used for abstract, the instrument types can be very different, ke karan is used only for causal, and for path, denoting the notion of path, may, say, these are used. In French, we find that the instrument is captured by these words. Okay. So, we can put them together in a set. Of course, there are fine shades, okay, and not everything is replaceable with each other, and the syntactic structure is given by means of these kind of frames. In German, again, we have instrument captured by a number of such words. Of course, there are shades and nuances, but we see them grouped together because they can capture the notion of instrument with different facets. Of course, abstract notion was described with facets, so their facets can be different. Malay is an interesting case, the language Malay. They introduce instrument in three different ways: preposition plus NP, affixes, and compounding. Okay. So, the prefix ber, for example, produces the word ber kuda, which means on horseback. Prefix and suffix both can be used. For example, men and kan. So, mema kukan means to fasten with nails. Okay. The whole preposition is both abstract notion and facet is captured through prefix and suffix.
Actually, this is derivation morphology, membrican, etc. And that is not something you can analyze as prepositions, etc.
No, no. I'm just talking about equivalence.
But you know, it's not the way to mean an instrument in the analysis of maximum bottom. You have mem alone, and you have also mem can applying together, as you say. But it's it cannot be said to express the instrument like instrumental case or with, etc., like you did in German. I don't think so. It's derivation. It's a lexicosemantic function going from one word to another.
Yeah.
It's like westbound in English, you see?
It's a compound.
Westbound. Okay. But westbound does not mean something like
to the west.
to the, yeah.
It means to the west, right?
Yeah, but it doesn't mean like to. Alors, see.
Yeah, sure. So I think the this is a concern in machine translation. The equivalent of preposition in English can be very complex in the target language, and most probably only statistical machine translation can capture those idiosyncrasies, I would say. No?
To die, to ride, that's all.
But can you capture them by rules? I don't know. No, all kinds of.
You capture that, you simply put it in the dictionary, you say that it's like to land on ground and to land on water. Okay, for English you have no way to express that with a simple word, but in French you have simple words. Amérir, atterrir. But whether you find it by, you know, statistical means on corpora, or first you go through a corpus that is called a special kind of corpus called a dictionary, because people have done it before. That knowledge can be simply consigned in translation and derivation tables.
Yeah, the point I'm making is that both information retrieval and machine translation and things needing inferencing, like question answering, for example, they do find extreme challenge when dealing with prepositions. And all these lexical resources to capture prepositions, which are again multilingual in character, would have to worry about this. I think the main contribution from PrepNet is the notion of abstract notion and facets. That's a nice way of capturing nuances of prepositions. Okay, so I think I should finish now, and there are also important resources like Wordnet and PropBank, very, very important resource.
And I want to say something. I will send you a reference on kappa coefficients.
Yeah, maybe I can also do it.
The real one is, as I say, -1 + 1 statistics. It dates back to 1892. But there are some references put there that are totally wrong, perhaps, but they mention 0 and 1. And simply, with the same formula, simply they are not able to see that the formula entails a domain between -1 and +1. Very strange.
Yeah, I think for kappa score, the important notion is of contingency table.
Yeah.
Okay, and how you work with the contingency table.
-1 is total disagreement.
Yeah.
0 is totally dependence. 1 is total agreement.
Okay, so just want to finish by saying that
this explains why this kind of doubt sometimes in the community about that. I saw it in the thesis by Violeta Serretan. I was a reviewer, and I hit on that problem of somebody writing formulas with a kappa, and I saw that the values were not in the proper domain, and I went to the web, etc.
Okay, so on verbs there is a lot of work going on. Verbocean is one of the recent resources, and it adds new relationships for verbs. And I would like to say that when you compare lexical resources, we find constructive, differentiative, definition-oriented, generative, uncentralized. Then they are differentiated on method of construction, on representation, and coverage and quality. I will leave these slides, of course, and then hopefully this will be useful. Okay, thank you.